So, example of good names versus bad names, right? So, illegal character using digits and so forth using keywords is not allowed. Use meaningful names. This is a very typical C++ style, using underscore to separate words, and pretty much all lowercase is fine. Now, bad names, these would be confusing because the meaning is hard to follow, right? So acronyms, abbreviations can be okay with people working in a certain program domain, like tax code or healthcare, health insurance, or all sorts of things like medical coding, special type of equipment. There's all sorts of abbreviations and acronyms. But if you're expecting to hire more people, to make it more friendly to share the code base with other types of audiences, don't stick too much to this, abbreviations and acronyms and things like that. Just use more or less readable types of identifiers. Single character names already told you. Something that's too long is like the number of elements. Okay, you can just say element count or number, number of elements, but this is too much, right? Very long identifiers. And also, do not begin your variable names and anything else with underscores. Especially in C library, underscores in front of identifiers are reserved for parts of the library. So sometimes it's not a typical situation, but if for some reason you named it like this and you have some horrific error message, just realize that, oh, I just used underscore in front of my thing and it's in collision of something else in the library, and it will give you some kind of very strange error which you never expect. If you're tempted, so do this. This is perfectly fine, okay? Underscore after the name is just, if for some reason you wanted to do something like that, perfectly legal, and if it makes your life easier, you can do it, right? But in general, not in front. Arithmetic operators, of course, are pluses, minuses, multiplication, and division. But in addition, you can do things such as square root and use library functions on numbers. So that's a different story. So, for instance, if I wanted to display square root of this count, right, I would know to include CMath, I think, right? And once I define, once I include CMath, all typical library math functions become available, and now I can say stdcout and print square root of I don't know, count, right, which is currently 6. So we should be able to see what it does if we highlight it like this. Okay, you can see that square root returns square root of 6, and then let's also add the new line. If some of these statements become too long and too confusing, remember you can break them down to multiple lines and even separate individual pieces that we're sending to cout into separate parts. Okay, so but let's run this and see what is the square root of 6, I suppose, right? So count is 5 originally, then it becomes 6. So let's just move this to a little closer to where it belongs, right here, right? So we have count 5, increment makes it 6, and then we display what is the square root. Let me build this first and run it. So the outcome is, this is what my computer returns, and this is the result that it prints. right here, right? So supposedly 2.4 times 2.4 should be approximately, close to 6. Okay, so again, all math functions are there. Do not invent them. You don't have to code them. Typically, all sorts of very typical manipulations are available directly from the library. Now, again, if you continue to use stdlib facilities.h that came with the textbook, you can forget about these includes. Otherwise, you have to remember them and use them appropriately. Normally, we say that our functions encapsulate computations, right? Computation, example of computation is simply applying a certain formula or sorting elements of an array or searching for something. All of this in general refers to as being used as a computation, something that consumes resources of your computer. So we spoke about these fundamental types. There are actually two kinds of floating point numbers, real numbers or fractional numbers. There's float and there's double. Float, by the way, it typically is the same size as int, and double is normally used by default. This is the first choice of floating point data type, is like double precision, twice as big as float. But float is used for graphics, right? So when you define your geometry and when you define your textures and all other parts of graphics that you want to use in your graphics card and like in your 3D environment, precision there is only as accurate as 1 pixel on the screen. So a floating point arithmetic with floating point data type normally is used in 3D graphics. Everywhere else, the default choice should be double.